The question itself feels like a kind of heresy, a challenge thrown at the feet of everything we think we know. What lies beyond the edge of the universe? It conjures images of a cosmic cliff, a precipice where galaxies give way to an infinite black nothingness, or perhaps a realm of pure, chaotic energy. We are drawn to edges, to boundaries. They define our world and ignite our curiosity about what exists on the other side. But to even begin to approach this question, we must first dismantle our most basic assumptions, for the universe, in its profound and elegant strangeness, refuses to conform to our terrestrial intuitions. There is no stone wall inscribed with the words, "Here be dragons." The true nature of the cosmic frontier is far more wondrous and far more perplexing than any ancient mapmaker could have dreamed. First, we must define this so-called edge. When cosmologists speak of the observable universe, they are not referring to a physical boundary, a shell containing all of existence. Instead, they are describing a limit set by the most fundamental constant in the cosmos, the speed of light. Light, while unimaginably fast, is not instantaneous. It travels at a finite speed, and so, when we gaze outward into space, we are also gazing backward in time. The light from the sun takes 8 minutes to reach us. We see it not as it is, but as it was 8 minutes ago. The light from the Andromeda galaxy is 2.5 million years old, showing us a version of that celestial island from a time when humanity's ancestors were just beginning to walk upright on the plains of Africa. This principle extends to the very limits of our vision, the cosmic horizon. The absolute edge of what we can possibly see is the point from which light has been traveling towards us for the entire age of the universe, roughly 13.8 billion years. This horizon is not a place you could ever visit. It is a barrier in time, not space. Imagine yourself as a point at the center of an expanding bubble. The surface of that bubble is the horizon. As time passes, the bubble grows, and light from previously unseen regions finally has time to reach you, pushing your horizon outward. The most distant, and therefore the oldest light we can detect is the cosmic microwave background radiation, a faint, cold glow that permeates all of space. This is the remnant of the hot, dense plasma that filled the universe just 380,000 years after the Big Bang, the moment when the cosmos cooled enough for atoms to form and for light to finally travel freely. When we observe this background, we are essentially looking at the inner surface of our observable bubble, a fossilized snapshot of the infant universe. So the edge is all around us, a spherical shell etched onto the sky, and it is defined not by where we cannot see, but by the light that has only just arrived. But this leads to an even dizzying realization. If the observable universe is a sphere 93 billion light-years in diameter, centered on us, what about an alien astronomer in a galaxy near our current horizon? Their observable universe is also a sphere 93 billion light-years in diameter, but centered on them. Their cosmic horizon encompasses regions of the cosmos that are forever hidden from our view, simply because the light from those regions hasn't had time to reach us, and due to the expansion of the universe, it never will. We are all at the center of our own observable universe. This immediately shatters the idea of a single, universal edge. The frontier is personal, it is relative, and it is fundamentally unreachable. This brings us to the engine driving this entire cosmic drama, the expansion of space itself. In the 1920s, Edwin Hubble made the startling discovery that nearly all galaxies are moving away from us, and that their speed of recession is proportional to their distance. The farther away a galaxy is, the faster it appears to be fleeing. The most intuitive and ultimately incorrect explanation is to imagine the galaxies themselves rocketing away from each other through a static, pre-existing void, like shrapnel from an explosion. But the reality, as described by Einstein's theory of general relativity, is far more radical. It is not that galaxies are moving through space, but that the fabric of space itself is stretching, carrying the galaxies along with it. The universe is not expanding into anything. It is simply becoming more spacious. A common analogy is the surface of an inflating balloon. Glue a few paper dots onto the balloon. As you blow it up, each dot sees every other dot moving away. From the perspective of any single dot, it is at the center of the expansion. There is no center on the balloon's surface, and the surface itself is not expanding into anything. It is simply the two-dimensional fabric that is growing. Our three-dimensional universe is analogous to that balloon's surface, but with one more dimension. This expansion has a profound consequence for the cosmic horizon. For the most distant galaxies, the space between us and them is stretching so fast that light they emit today will never reach us. They have already passed beyond our event horizon, receding into a future of permanent isolation. The light we see from them is ancient, a ghost image from a time when we were closer together. The universe is not just hiding its distant realms, it is actively and relentlessly taking them away from us, severing the connective threads of light one by one. So, if we were somehow able to travel instantaneously to our current cosmic horizon, what would we find? There would be no wall, no barrier, no edge. We would simply find more universe. We would now be at the center of a new observable sphere, and we could look back towards our own Milky Way, seeing it as it was 13.8 billion years ago. The horizon would have moved with us. The concept of an edge is, in this sense, a mirage. It is a limitation of our perspective, a consequence of the finite speed of light and the relentless expansion of the cosmos. We are like sailors on a vast, foggy ocean. Our horizon is determined by how far we can see through the mist, but we know the ocean continues far beyond. The true, full extent of the universe, what cosmologists call the whole universe, could be vastly larger than the portion we are privy to. It could be infinite.
And if it is infinite, then the question of what lies beyond becomes not a question of geography, but one of metaphysics. But infinity is not the only possibility, and the nature of what lies beyond our sight is the realm where established science ends and the most breathtaking speculation begins. If the observable universe is but a single, finite bubble within a potentially infinite whole, then the nature of that whole becomes the greatest mystery in cosmology. We are trapped within our causal sphere, unable to receive any information, any signal, any photon from what lies outside our cosmic horizon. This is the ultimate quarantine. Yet the human mind is not so easily contained. Armed with the laws of physics, mathematical extrapolation, and a healthy dose of philosophical daring, we can propose models, theories, and speculations about the greater cosmos. These are not wild guesses, but logical extensions of our current understanding, each painting a radically different picture of reality on the grandest scales. One of the leading and most mind-bending theories is that of eternal inflation. This concept suggests that the Big Bang was not a unique, singular event, but rather a local phase transition within a much larger and eternally expanding meta-universe. Imagine a vast boiling ocean of primordial energy, a multiverse of sorts, in a state of hyper-fast, inflating space. In this frenetic sea, bubbles of stability spontaneously form, like pockets of steam and boiling water. Within each of these bubbles, the inflationary energy decays, releasing its pent-up potential to create a hot, dense soup of particles and radiation, a Big Bang. Our entire observable universe is just one such bubble, one island of stability in an infinite, eternally inflating sea. What lies beyond our horizon, then, is not mere empty space, but the raw, inflating background from which we crystallized. And in that background, an infinite number of other bubbles are constantly nucleating, each giving rise to its own separate universe, with its own unique laws of physics, its own constants, its own dimensions. In this view, beyond the edge is an infinite infinity of other universes, a cosmic foam of realities, most of which would be utterly alien and unrecognizable to us. This idea of a multiverse is not a single theory, but a spectrum of possibilities. Another version arises from string theory and the concept of the string landscape. This suggests the fundamental constants of nature, like the strength of gravity or the mass of an electron, are not necessarily fine-tuned for life by some grand design, but are instead frozen accidents, the result of how additional, hidden dimensions of space-time became compactified in our particular cosmic bubble. The number of possible stable configurations is astronomically large, perhaps 10 to the 500 or more. This vast landscape of possible physical laws could be realized across different bubble universes in an inflating multiverse. So beyond our horizon, we might find universes where gravity is repulsive, where time runs backwards, or where the very concept of an atom never coalesced. Some might be stillborn, collapsing instantly upon formation. Others might be vast, empty deserts where matter never clumped into galaxies. We exist in one that is, by definition, hospitable to our form of life, a consequence of the anthropic principle. But the multiverse is not the only contender. Another profound possibility is that the entire universe, the true, whole universe, is geometrically finite, yet without an edge. This is a concept our brains are ill-equipped to visualize, but mathematics handles it with ease. Consider the surface of the Earth. It is a finite, two-dimensional surface, yet if you embark on a long journey, you never encounter a precipice. You simply return to your starting point. It is unbounded. Now extrapolate this idea to 3 dimensions of space. A finite, yet unbounded universe would mean that if you could point a powerful enough telescope in any one direction and look far enough, you would not see a distant alien galaxy, but the back of your own head, witnessing the light that left it billions of years ago. The universe would wrap around itself. In such a cosmos, the question, what lies beyond the edge, is meaningless, because there is no beyond. The cosmic horizon is not a boundary to a larger exterior, but simply the limit of how far we can see within a closed yet immense cosmic loop. All of existence is contained within this finite volume. The outside would not be a spatial dimension, but perhaps something else entirely, a higher dimensional bulk into which our 3-dimensional space is embedded, like the surface of a balloon exists in our 3-dimensional world. Then there are the more exotic and more speculative ideas. What if our universe is not the top-level reality? The holographic principle, born from the study of black holes, suggests that all the information contained within a volume of space can be encoded on its boundary surface. Some physicists have taken this a step further, proposing that our 3-dimensional universe, with all its galaxies, stars, and planets, is in fact a holographic projection from a 2-dimensional surface that exists at our cosmic horizon. In this radical view, the question of what lies beyond the edge is turned on its head. There is no beyond in a 3rd dimension of space, because the true, fundamental reality is the 2-dimensional shell we call the horizon. We and everything we perceive are a complex hologram generated from that distant surface. asking what's beyond is like a character in a movie asking what's behind the screen. The question arises from a misunderstanding of the nature of their reality. Alternatively, we must consider the stark possibility that the question is, scientifically, nonsensical. In the framework of general relativity, the universe is all there is. Space and time were created in the Big Bang. To ask what is outside the universe is like asking what is north of the North Pole. The concepts of outside and before may simply not apply. The container of space-time itself does not reside within a larger container. This is, perhaps, the most intellectually challenging concept to accept, as our language and logic are built upon a framework of cause and effect within a pre-existing stage. To be told the stage itself is the entire show is a profound paradigm shift.
Each of these theories, the infinite multiverse, the finite but unbounded cosmos, the holographic projection, attempts to solve the puzzle of the whole universe. They are currently untestable, residing in the domain of theoretical physics, yet they are not mere philosophy. They make different, subtle predictions about the patterns we might see in the cosmic microwave background, the fossil light from the universe's infancy. A finite, wrapped universe might leave imprints of its topology on this background radiation, like a hall of mirrors creating specific patterns. The theory of inflation predicts a specific spectrum of gravitational waves, ripples in spacetime from the initial violent expansion, which future observatories may one day detect. We are, in a sense, cosmic detectives, trapped in a single room of an impossibly vast mansion, trying to deduce the blueprint of the entire structure by examining the cracks in the walls and the faint, distant echoes that reach our ears. The pursuit of what lies beyond our sight is more than a scientific endeavor. It is a fundamental expression of human consciousness, a journey that forces us to confront the very nature of reality, knowledge, and our place within the cosmos. While our telescopes cannot pierce the cosmic horizon, our minds can, and in doing so, we are compelled to navigate the nebulous boundary where empirical science bleeds into profound philosophy. The ultimate limitation may not be one of distance or technology, but of the very framework of our understanding. Are we, with our three-dimensional brains and our language built on cause and effect, even equipped to comprehend the answers? This journey inward to the philosophical implications of the cosmic horizon begins with a humbling realization. We are not just geographically provincial, but temporally as well. Our entire civilization, from its first sparks to its potential future extinction, occupies a mere sliver of cosmic time. The universe has been expanding for 13.8 billion years, and based on current observations, it appears destined to continue for trillions more, eventually entering a dark, cold era where all stars have burned out and all black holes have evaporated. In this context of deep time, the period during which the universe is transparent and filled with luminous galaxies, the cosmic noon in which we find ourselves, is remarkably brief. We exist in a privileged moment, a golden age, where the cosmos is neither too dense and hot to be opaque, nor so expanded and dark that the horizon has receded to near nothingness, leaving future civilizations in a lonely, isolated island of stars. Our ability to even pose the question, what lies beyond, is a fortunate accident of our temporal coordinates. This leads to the anthropic principle, which shifts the focus from the universe at large to our peculiar position within it. In its weak form, it simply states that we observe a universe compatible with our existence because we couldn't exist in one that isn't. The constants of nature, the strength of gravity, the mass of a proton, the cosmological constant, appear finely tuned to allow for galaxies, stars, planets, and life. The multiverse theory offers one potential explanation for this apparent fine-tuning. If an infinite array of universes exist, each with different physical laws, it is no surprise we find ourselves in one of the rare, hospitable ones. But the philosophical implications are staggering. It suggests that our entire reality, with all its beauty and complexity, might be a statistical fluke, one lucky ticket in a cosmic lottery of mostly barren or unstable universes. The edge of our universe, then, is not just a boundary of light, but a boundary of physical law, separating our ordered reality from a potentially infinite chaos of other possibilities. But the most profound limitation is that of consciousness itself. Our perception of reality is a model constructed by our brains, filtered through our senses, and interpreted through the lens of language and mathematics. This model is exquisitely adapted for survival on the African savanna, not for comprehending the quantum nature of space-time or the possibility of 10 spatial dimensions. Concepts like before the Big Bang or outside the universe may be as meaningless to a full understanding of reality as the color blue is to a creature that sees only in infrared. We are like the ancient philosophers who debated the nature of atoms without any hope of ever seeing one, yet our tools are mathematics and observational data, allowing us to push the boundaries of the knowable further than ever before. The cosmic horizon is, therefore, as much a horizon of the mind as it is of the cosmos. So, where does this leave our original, seemingly simple question? The search for what lies beyond the observable universe has yielded not a single definitive answer, but a spectrum of breathtaking possibilities, each more incredible than the last. It has forced us to invent new concepts, inflation, the multiverse, quantum cosmology, and to question the very meaning of existence. The journey to understand the edge has, paradoxically, led us to a deeper understanding of our own cosmic home, revealing a dynamic, expanding, and evolving universe that is far grander and more mysterious than the static, eternal sphere of the ancients. The true value of this question may not lie in its eventual answer, but in the journey of inquiry itself. It is a question that has no practical application, no technological spin-off, no immediate bearing on our daily lives. Yet it is one of the most noble and defining pursuits of our species. To look up at the static, silent points of light in the night sky, and to see not a ceiling, but a doorway. To perceive in the faint, cold glow of the cosmic microwave background, not just a fossil, but a frontier. This is a testament to the human spirit. It is an act of rebellion against our limitations, a declaration that our curiosity extends beyond the barriers of space and time. Perhaps we will never know with certainty what lies beyond the cosmic horizon. The universe may forever keep its ultimate secrets. But in our relentless, audacious attempt to find out, we have mapped the infinitesimal quantum world and the vast cosmic web of galaxies. We have deduced the life cycles of stars and the origin of the elements that compose our very bodies. We have discovered that we are, in the most literal sense, stardust, the universe become conscious of itself. The quest to see beyond the edge has shown us that we are not merely passive inhabitants of a determined cosmos, but active participants in a grand, unfolding story of discovery. The final frontier is not just a line on a map of the sky. It is the limitless potential of the human mind to reach, to question, and to wonder.